Namaskar. Now, in the last session, we have observed how we can think about a active high input, that is gate flip-flop, RS flip-flop. Similarly, what is the active low? That means suppose here it is a bubble, means the active input to the active high gate is provided through a NOT gate, then we can say that it is active low. Means the circuit will be active, it will give the response to RS input whenever the gate input is low. Now in both the cases, when the gate is high for a long time, obviously, and here when the gate is low, the circuit is active. But suppose if we will have to make the circuit active only for a very small interval of time, that means what happens here, suppose if we provide the gate input which is in this form, suppose, correct, then from this time interval to this time interval the circuit remains active, and we will have to take care that the inputs R and S should be proper or should not change because the circuit is active. Now is it possible that the active high, say for example circuit, is active for a very short time interval? Is it possible? If it is so, then it will be better. Why? The reason will be very simple. We will keep the required inputs R and S, then we will make the circuit active and immediately it is deactivated, and this will be helpful for us. And such a circuit or such type of the trigger is known as age trigger. That means the circuit is activated only for this age. Now we know that in actual circuit it should be high or low for certain time interval, it should be high or low, correct? But now it happens or it takes place only for a short time interval, either on rising age, or it may happen that it will be activated for this falling age. Now here our assumption is that it is active high, this is also active high, but as it will take place only on the rising age in this case or during falling age in this case, it can be treated as age trigger. Means instead of a level trigger, for a long time it remains high, it will not remain long time high. And how it is possible to convert a fixed width to a very small, that is narrow width? A simple circuit can be used, a simple circuit. Now suppose if I provide this as an input to a circuit, something like this, now one more component is to be added here, but we will add this later on. Now we know that for a DC input, that means if the input is static, either it is low, or I will draw here, it is either it is low, this part, or it is high, the capacitor acts as open circuit, and the output remains low. It is connected to ground, here it is ground, so it remains low. Therefore if I will have to draw the timing diagram simultaneously, here I will represent the input, let this is the input, okay, and I will have to draw the output. Therefore here I can draw up to this, output remains low, from this it remains low, again here it remains low, here it remains low, here it remains low. But what happens if there is sudden change in input from 0 to high, that is low to high, 0 to 5 volt, sudden change. For a sudden change, capacitor acts as short circuit. Now this is very interesting feature of the capacitor. For a DC, capacitor acts as open circuit, while for a AC, capacitor offers some resistor. We know that. And what is the rising edge? Rising edge is the AC signal. There is a change, and for this sudden change, capacitor acts as short circuit, and so this change appears as a output. Therefore, if this is input, this is output, this change appears in the output, but as it remains high for a long time, capacitor gets charged, and again the output reduces to 0. Correct? Again the output reduces to 0. Here what happens? Now the capacitor is fully charged, but this terminal is low again. Therefore here it is 0, here it is 5 volt. Capacitor is charged. Now if suddenly it becomes low, see how input becomes low, this terminal, which is negative terminal of the capacitor, provides a negative voltage to the output. Negative voltage to the output, and the capacitor discharges slowly. Right? Discharges slowly. Again, for the rising edge of the clock, I will call it, this is clock now, or gate input. The capacitor provides a positive input, decreases to 0, and for a falling edge of the clock, the capacitor provides negative input and reduces to 0. Therefore, this will be the output of this circuit. Correct? Output of this circuit. Now, yes, it is possible. Therefore, for a very small time interval, the output remains high and the gate can be open, and for rest of the time it remains low. And so if we provide this as a input to the gate, we can treat it as a edge trigger, because it will be activated only for the edge. Now remember that it is not an instant, it should be certain interval. But this instant can be converted into a narrow interval, very small interval, with help of this circuit. Correct? With help of this circuit. But as it is very small, it can be treated as a trigger on an edge only on edge, not level. Right? But there is a problem of these negative going edges, spikes. Negative going spikes. How to eliminate this? To eliminate this, we can add a diode here. Now if I add a diode here, something like this, now what happens? If this is negative, somewhere here it is negative, the diode conducts, because this is grounded, it is negative, it is 0, correct? But if it is negative, the diode conducts and it will block this. So in presence of the diode, that means in presence of such complete circuit, the output will be something like this. Now I am showing a very small low going or negative, because for the forward bias diode 0.7 volt is essential across this, and so it is like this. 0, it rises, decreases, here it is almost 0, means in presence of this circuit, before the actual gate of RS flip-flop, the output becomes, or input to the gate becomes like this. So you will realize that only for a very small time interval gate will be open, Therefore, the output of the RS flip-flop will change in accordance with RS inputs, and otherwise the gate is closed and so output will not affected by the input, right? And hence, if I connect the circuit something like this, okay, finally what I will have to do, this is my RS flip-flop, I will call this as gated RS flip-flop. Therefore, R input, S input, Qn output, Qn bar output, and right here it is R, S, Qn and Qn bar. This is gate. And now if I provide input to the gate by means of this circuit, here it is capacitor, then there is a resistor, it is connected to ground, then there is a diode connected to ground, and this as a input. Then what will happen? Then interesting situation is that though I connect a clock here, high-low going pulse, this will be activated. Here the signal will be something like this only, correct? Therefore, this will be activated only for the rising edge of the clock, only for the rising edge of the clock. And now I will call this as clock. It is CK, clock. Okay, means only for the rising edge of the clock the flip-flop will be activated. And now what will happen? It checks what is the present status of R, present status of S, and accordingly it will change the output when there is rising edge of the clock. And symbolic representation of such type of flip-flop is, I will call this as RS flip-flop, Here it is R, here it is S, and now I will call it as edge trigger. Now see, yesterday we were showing it as a level trigger. There is no triangle. There is bubble, means it is complement, it is low level trigger. Now here I can say that it is edge trigger, and here I will call it as clock, CK. Now as the output changes for the rising edge, the reason is very simple. For the rising edge, the output becomes high for, the gate becomes high for a very small time interval. But suppose there is a NOT gate before that, the same thing happens at a falling edge. And so, I can show one more possibility that this is R, this is S, and I will draw a bubble and triangle, correct? And triangle. So, this is the negative edge trigger. This is the positive edge trigger. That means the output changes during positive edge, during rising edge. And here the same thing happens on the falling edge, and so it is known as negative edge trigger or falling edge trigger. Here it is rising edge trigger. The name itself suggests it triggers the output Qn, and obviously Qn bar changes in accordance with input R and S during rising edge of the clock. Check the statement carefully. The output Qn and hence Qn bar changes in accordance with present R and S, but when? During rising edge. What is the status of R and S? At this moment, accordingly the output will change, and otherwise it will not give the response. Similarly, it takes place during falling edge. Okay, so we shall draw a timing diagram here. Now the timing diagram is very interesting. Suppose this is our clock provided to this RS flip-flop, that is a rising edge trigger RS flip-flop, and I will draw the corresponding R and S also, correct? R and S also. Now you will realize the interesting feature of such type of flip-flop. Check. Now this is clock to this RS flip-flop. This is R input. This is R input. This is S input. And what we will have to do? We will have to draw the QN. Correct? We will have to draw the QN. Now suppose R and S are 0 somewhere here for the first rising edge. Then now we will discuss later on, but now I will draw some circuit and then I will let you know why I am drawing something like this. Okay, this is the situation. Now so many possibilities can be represented in this timing diagram, but we will represent few of them. Now see, here R is 0, S is 0, therefore this Q remains Qn bar, right? Now apparently we feel that here S becomes 1. Apparently we feel that here S becomes 1. So flip-flop should set here. We feel that. But it will not happen. Why? A very simple reason is that it is edge trigger flip-flop. Edge trigger. That means whenever the clock rises, only for that small time interval, output will be changed in accordance with the present input. So we will have to ignore all these timings. Only we will have to focus on this. For this rising edge, what is the status of R? R is 1. What is the status of S? S is 0. And so flip-flop gets reset. It becomes 0 because it is 1. What happens between this to this interval? There is change in S. S becomes 1, becomes 0, then R becomes 0, S remains 1. But I will have to ignore all those instances. When the flip-flop will give the response? Only for the rising edge. Therefore, for the rising edge, R is 0, S is 1, and so it sets. For the rising edge, R is 0, S is 0, and it remains as it is. It remains as it is, continues. What happens here? Suppose here intermediate change is there, intermediate change may be there, but the last situation for this rising edge is R is 1, S is 0, and so it resets. Right? So the advantage of edge trigger flip-flop is that it ignores the intermediate changes in the input in between two rising edges, this to this, this to this. Intermediate changes are ignored. And the flip-flop gives the response to the input only during the rising edge. Correct? So my statement was very clear. What happens? Output changes when only for the rising edge of the clock, only for the rising edge of the clock, in accordance with the present inputs. What are the inputs? At the rising edge, at the rising edge, at the rising edge, at the rising edge. Accordingly, the output will change. Okay? So, now homework for you. How the output changes for the negative edge trigger RS flip-flop. This is RS flip-flop, but it is negative. There is a bubble. Edge trigger. Right? Now what you will have to do? You will have to draw the clock. You will have to draw the different combinations of RS inputs, and accordingly you will have to prepare the output Qn and Qn bar also. Now there are so many possibilities. You can imagine different possibilities of R and S inputs. Now see here, several times if I change R, several times if I change S, there is no issue because these changes will be ignored in intermediate, right? Now what you will have to do, you will have to prepare for the falling edge. Now let us check what you will do. So, as a summary, there are 4 types of flip-flops. One, this is known as positive level trigger. That means whenever the input is high, it gives response to R and S input. It is negative or negative level trigger. That means whenever the input is low, that is gate or clock is low, the output changes in accordance with the R and S input. Here it is positive edge trigger. That means this is positive edge trigger. Only during the positive edge, what are the inputs R and S? Accordingly the output will change only during positive edge. And this is negative edge trigger. That means the output changes in accordance with the input only during negative edge of the clock. Correct? Now homework, prepare the truth timing diagram for such type of RS flip-flop. Thank you.